Does friendly have a taste? If it does, it's probably like Hello's peppermint-flavored anti-plaque and whitening toothpaste. Brush away plaque, show tartar who's boss, and remove surface stains to naturally whiten. Hello's thoughtful and flavor-forward products make brushing your teeth feel like a confetti-filled bathroom dance party. So say hello to Hello with the always cruelty-free, never tested on animals toothpaste that's made to spread smiles. Visit HelloProducts.com and let Hello add some everyday yay into your life.
There's a time and a place for filet of fish. But breakfast is for sausage biscuits. McDonald's breakfast comes first. Ba-da-ba-ba-ba.
This is SpaceTime, Series 28, Episode 92, for broadcast on the 1st of August 2025. Coming up on SpaceTime, searching for life's home on Mars. A rare distant object in the outskirts of the solar system found in perfect synchronicity with the ice giant Neptune, and mapping sulfur, essential for life as we know it, throughout the Milky Way galaxy. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study has been looking at thick layers of clay on the surface of the red planet Mars, which would have been a stable place for life on this ancient world had it ever existed there. Mars is home to thick layers of clay that can span hundreds of metres. Since they need water to form, these outcrops have long been of interest to scientists looking for signs of past life on the red planet. Now, a report in the journal Nature Astronomy has taken a closer look at some of these clay terrains, and they found that most form these standing bodies of surface water, which were common on Mars billions of years ago. This environment would have fostered the chemical weathering needed to create thick mineral-rich layers of clay and could have provided the right mixture of water, minerals and a calm environment for life to develop. The study's lead author, Rhianna Moore from the University of Texas, says these areas had a lot of water but not a lot of topographic uplift, so they were very stable. And if you have a stable terrain, you're not messing up your potentially habitable environment. Favourable conditions might be more able to be sustained for longer periods of time. Moore and colleagues also found that these thick clay layers may also have been a sign of an imbalanced water and carbon cycle on ancient Mars. And that would explain why the red planet appears to be missing carbonate rocks in environments where they would normally be expected to be found on Earth. Billions of years ago, Mars was a warm, wet world, with lakes and rivers and even an ocean. These created geological formations that are carved onto the surface of the planet today, and the thick clay layers formed during this wet period. However, before this study, little was known about the environments in which they formed, and how the surrounding terrain would have influenced their evolution. Moore and colleagues analysed images and data from 150 clay deposits that had previously been analysed using a global survey conducted by NASA's Mars Reconnaissance Orbiter. The authors identified trends in the topographical characteristics and how close they were to other geological features, such as former bodies of water. They found the clays were mostly located at low elevations, near lake deposits, but away from valley networks where water was thought to have been flowing more vigorously across the terrain. This balance between chemical and physical weathering led to their preservation through time. The Martian clay environment is similar to tropical places with thick clay layers found here on Earth. On Earth, the places where we tend to see the thickest clay mineral sequences are in humid environments, and those with minimal physical erosion that can strip away newly created weathering products. The results suggest that the latter element is also true on Mars, while there are hints of the former as well. However, the clays also reflect an ancient Martian world that was very different from the Earth of today. On Earth, shifting tectonic plates are consistently exposing fresh rock that can steadily react with water and carbon dioxide in the atmosphere, which helps regulate the climate. However, Mars lacks tectonic activity. When Martian volcanoes released carbon dioxide into the atmosphere, the lack of a source for new reactive rock would have led the greenhouse gases to linger, causing the planet to become warmer and wetter. The authors suggest that these conditions may have contributed to the formation of the clays, and the lack of new rock on the surface may well have impeded the chemical reactions needed to form new carbonate rocks that would normally form from volcanic rock that underlies most Martian geology, given carbon dioxide, water and time. Ongoing clay formation on Mars may well have contributed to the dearth of carbonates there by sucking up water and sequestering chemical byproducts in the clay, rather than having them leach out into the wider environment where they could react with the surrounding geology. This is SpaceTime. Still to come, a rare distant body in the outer solar system found in perfect synchronicity with the planet Neptune, and a new study mapping the Milky Way's sulfur distribution, sulfur being one of the essential elements for life. All that and more still to come on SpaceTime. Astronomers have discovered a rare celestial body in the far outer reaches of our solar system, well beyond the orbit of Neptune, which appears to be moving in synchronicity with the ice giant. The object, catalogued as 2020 VN40, belongs to a class of celestial bodies known as trans-Neptunian objects. And it's the first confirmed body that orbits the Sun once for every 10 orbits Neptune completes. The discovery, reported in the Planetary Science Journal, will help astronomers better understand how objects in the outer solar system behave and how they got there. It supports the idea that many distant objects are temporarily caught in Neptune's gravity as they drift through space. The study's lead author, Rosemary Pike, says this discovery is a huge step forward in understanding the outer solar system. It shows that even very distant regions influenced by Neptune can contain objects, and it provides new clues about how the solar system evolved. The discovery was made by the LIDO, Large Inclination Distant Objects Survey, which looks for unusual objects in the outer solar system using the Canada-France-Hawaii telescope. The survey was designed to search for bodies with orbits that extend far above and below the ecliptic. That's the plane where Earth and most other planets orbit around the Sun. The LIDO survey's already found more than 140 distant objects. It's all part of the outer solar system that hasn't yet been well studied. 2020 VN40's average distance is about 140 times further out from the Sun than the Earth, and it follows a very tilted orbit around the solar system. What makes the object even more interesting is how it moves compared to Neptune. Most objects with a simple ratio of the duration of their orbit compared to the duration of Neptune's orbit, what's known as a resonance, always come closest to the Sun, where Neptune's furthest away. In contrast, 2020 VN40 comes closest to the Sun, where Neptune's also very close by. That's if you look at their positions from above the solar system. See, the tilt of 2020 VN40's orbit means that the objects aren't actually that close, because 2020 VN40 is actually far below the solar system's plane. They only appear that close when you flatten out the map. All other known resonant trans-Neptunian objects orbit in such a way as to avoid this alignment at their closest approach to the Sun, even in the flattened view. The findings suggest that these highly tilted orbits can lead to new and unexpected types of motion. And that could mean new discoveries. Maybe even a Planet 9. This is SpaceTime. Still to come, mapping the Milky Way's sulfur distribution, the red supergiant Antares, the second nearest star system to the Sun, Barnard Star, and the annual Perseids meteor shower are among the highlights of the August night skies on Skywatch.
Thanks for selling your car to Carvana. Here's your check.
Whoa, when did I get here?
What do you mean?
I swear it was just moments ago that I accepted a great offer from Carvana online. I must have time traveled to the future.
It was just moments ago. We do same-day pickup. Here's your check for that great offer.
It is the future.
It's the present and just the convenience of Carvana. Sorry to blow your mind.
It's all good. Happens all the time.
Sell your car the convenient way to
Carvana. Pickup times may vary and fees may apply.
A new study has provided astronomers with an unprecedented tally of elemental sulfur spread between stars in the Milky Way galaxy. Sulfur is important for how cells function in living creatures here on Earth. So, understanding its distribution on an interstellar scale is important for understanding how widespread life could be. One of the study's authors, Leo Corrales from the University of Michigan in Ann Arbor, says science still has a lot of questions about where sulfur is found in the universe. Sulfur can easily change from a gas to a solid and back again. To try and answer this puzzle, scientists have turned to the joint NASA and JAXA, that's Japanese Aerospace Exploration Agency, CRISM X-ray Imaging and Spectroscopy mission spacecraft. It provides the resolution and sensitivity needed to find sulfur in both its solid and gaseous forms, and to learn more about where it might be hiding. Astronomers used X-rays from two binary star systems to detect sulfur in the interstellar medium. That's the gas and dust found in the space between stars. It's the first direct measurement of both sulfur's gas and solid phases, a unique capability of X-ray spectroscopy, which is CRISM's primary method of studying the cosmos. The findings, reported in the publications of the Astronomical Society of Japan, used ultraviolet light to find gaseous sulfur in the space between stars. In the denser parts of the interstellar medium, such as molecular gas and dust clouds, where stars and planets are born, this form of sulfur quickly disappears. Scientists have always assumed that sulfur condenses into a solid, either by combining with ices or mixing with other elements. When a doctor performs an X-ray here on Earth, they place the patient between the X-ray source and a detector. Bones and tissue absorb different amounts of X-ray light as it travels through the patient's body, creating a contrast in the detector. To study sulfur, Corrales and colleagues did something similar. They picked a portion of the interstellar medium with the right density, not too thin so that all the X-rays would pass right through unchanged, but also not so dense that they'd all be absorbed. They then selected a bright X-ray source behind that section of the medium, a binary star system called GX340 plus 0. It's located some 35,000 light-years away in the southern constellation Scorpius. Using the Resolve instrument on CRISM, the authors were able to measure the energy of the star system's X-rays and determine that sulfur was present not only as a gas but also as a solid, possibly mixed with iron. Chemistry in environments like the interstellar medium are very different from anything seen on Earth. But Corrales and colleagues modelled sulfur combined with iron, and it seemed to match what they actually saw with CRISM. Iron-sulfur compounds are often found in meteorites, so scientists have long thought they might be one way sulfur solidifies out of molecular gas and dust clouds to travel through the universe. The authors were also able to use measurements from a second X-ray binary catalogued as 4U1630-472 to help confirm their findings. NASA's Chandra X-ray Observatory had previously studied sulfur, but CRISM's measurements are far more detailed. Since GX340 plus 0 is on the other side of the galaxy from Earth, CRISM's X-ray observations have provided a unique probe of sulfur across a large section of the Milky Way. This report from NASA TV.
Sulfur. It's the fifth most common element on Earth. It also helped make our early world habitable and allows life to function now. But scientists have a lot of questions about where it hides in interstellar space. Using the CRISM satellite, astronomers have now X-rayed our galaxy's sulfur in unprecedented detail. Out in the vastness of space is the interstellar medium, the gas and dust between the stars. Scientists see lots of sulfur as gas in molecular clouds, cold, dense patches of the medium where stars and planets are born. But this type of sulfur tends to disappear quickly. Where does it go? To find out, scientists picked a region of gas and dust that wasn't too thin or too thick. Then they picked a bright X-ray source behind the patch so that the light would pass through it on its way to CRISM. This is like getting an X-ray here on Earth, but instead of the light being absorbed by tissue and bone, it's absorbed by different elements, like sulfur. CRISM showed scientists that sulfur in the interstellar medium can be found as both a gas and as a solid, and possibly mixed with iron. This aligns with studies of meteorites and may help explain how sulfur moves through the cosmos. It's also the first direct measurement of sulfur in both solid and gas phases. Thanks to CRISM, we're a step closer to understanding how life on our planet came to be.
This is SpaceTime. And time now to turn our eyes to the skies and check out the celestial sphere for August on Skywatch. August is the 8th month of the year in the Julian and Gregorian calendars. It was originally named Sextilis in Latin because it was the 6th month of the original 10-month Roman calendar under Romulus in 753 BCE when the year started in March. It only became the 8th month when January and February were added to the start of the year. In the year 8 BCE, it was renamed in honour of the Roman statesman and military leader Augustus, who had achieved several military victories, including the conquest of Egypt during the month. Okay, turning to the heavens, and the constellation Scorpius the Scorpion is high overhead this time of year, covering almost a third of the August night skies. At the heart of Scorpius, located some 470 light-years away, is the red supergiant Antares. A light-year is a distance of about 10 trillion kilometres, the distance a photon can travel in a year at 300,000 kilometres per second, the speed of light in a vacuum, and the ultimate speed limit of the universe. Red supergiants have the largest diameters of any known star. They evolve out of main sequence stars with more than 8 times the mass of the Sun. A main sequence star is a star fusing hydrogen into helium in its core. When stars stop fusing hydrogen into helium in their core, the balancing act between gravity pushing a star's mass down towards the centre and energy from nuclear fusion in the core pushing outwards ceases, and gravity wins, causing the star to begin to collapse inwards, crushing the stellar core until the increase in pressures and temperatures trigger helium fusion. At the same time, a shell of hydrogen around the core begins to fuse, causing the star's outer gaseous envelope to expand out into a bloated giant. And now, being further away from the core, the stellar surface starts to cool down, becoming redder in colour. While Sun-like stars will become red giants, those that are far bigger, 8 times or more the mass of the Sun, become red supergiants. Supergiants will fuse all their core helium into carbon and oxygen within just a few million years. They'll then begin fusing this core carbon and oxygen into progressively heavier and heavier elements until they eventually begin to produce iron in their core. Now, no star, no matter how massive it is big enough to fuse iron into heavier elements. And so then the star will collapse catastrophically in what's known as a core collapse supernova, an explosion bright enough to outshine an entire galaxy. The end result of this core collapse supernova will be the creation of either a neutron star or a black hole, depending on the progenitor star's mass. The name Antares means rival of Mars, and indeed when they're close together in the sky, they do look very similar. Antares, or Alpha Scorpii as it's sometimes called, has some 12.4 times the mass and an incredible 450 times the diameter of our Sun, and is one of the largest known stars in the universe. Antares is so big that were it placed where the Sun is at the centre of our solar system, it would engulf all the inner planets, Mercury, Venus, Earth and Mars. Its outer surface would reach almost as far as the orbit of Jupiter. Antares is a binary system. There's a companion star orbiting with it called Antares B, a massive spectral type E blue-white star, at least 7.2 times the mass and 5.2 times the radius of the Sun. It's located about 224 astronomical units beyond the primary star. An astronomical unit is the average distance between the Sun and the Earth, about 150 million kilometres or 8.3 light minutes. Astronomers describe stars in terms of spectral types, a classification system based on temperature and characteristics. The hottest, most massive and most luminous stars are known as spectral type O blue stars. They're closely followed by spectral type B blue-white stars, then spectral type A white stars, spectral type F whitish-yellow stars, spectral type G yellow stars, that's where our Sun fits in, spectral type K orange stars, and the coolest and least massive of all stars are spectral type M red stars, commonly referred to as red dwarfs. Now, each spectral classification is further subdivided using a numeric digit to represent temperature, with 0 being the hottest and 9 the coolest, and a Roman numeral to represent luminosity. Now, put all that together, and our Sun is a spectral type G2V or G25 yellow dwarf star. Also included in the stellar classification system are spectral types LT and Y, which are assigned to failed stars known as brown dwarfs, some of which were actually born as spectral type M red dwarf stars, but became brown dwarfs after losing some of their mass. Brown dwarfs fit into a category between the largest planets, which are about 13 times the mass of Jupiter, and the smallest spectral type M red dwarf stars, which are about 75 to 80 times the mass of Jupiter, or 0.08 solar masses. Located near Antares is the spectacular globular cluster Messier 4, or M4 for short. Named after the 18th century French astronomer and comet hunter Charles Messier, it's one of a catalogue of 103 fuzzy objects which weren't comets, and so were of no interest to Messier, and so he made a list of them, so he didn't waste his time looking at them. Other astronomers have since added further celestial objects to the catalogue, bringing the total to around 110. Located some 7,000 light-years away, Messier 4 can be seen through a pair of binoculars, making it one of the closest globular clusters to Earth. Globular clusters are densely packed spheres containing thousands to millions of gravitationally bound stars, which it's thought were either originally all born at the same time in the same stellar nursery, or are the surviving cores of galaxies that have been cannibalized by larger galaxies. They're almost always found orbiting the halo of galaxies. The Milky Way has about 150 of them, and they're all usually very ancient, some dating back to around 12 billion years. Located just below the sting of Scorpius are two open star clusters, M6 and M7. M7's the nearer of the two, located about 800 light-years away, while M6 is a more distant 2,000 light-years. Open clusters are less densely packed than their globular cluster counterparts, with the stars inside them less gravitationally bound and more prone to drifting away over time. Another open star cluster in Scorpius is NGC 6231, located about 6,500 light-years away, just near the star Zeta Scorpii. NGC 6231 is a bright open star cluster containing around 120 stars, including a significant population of highly luminous supergiants, numerous white-yellow stars, and at least 2 Wolf-Rayet stars. Wolf-Rayets are extremely luminous evolved stars reaching the ends of their lives. Having run out of hydrogen for core fusion, they're no longer on the main sequence and are instead fusing progressively heavier and heavier elements in their cores. This causes them to have surface temperatures of up to 200,000 degrees Celsius, and such extreme temperatures generate powerful stellar winds. Just behind Scorpius is the constellation Sagittarius, the half-man, half-horse of Greek mythology. And as we mentioned in last month's Skywatch, the centre of the Milky Way galaxy is found in Sagittarius, roughly 27,000 light-years away. The name Sagittarius could be traced back beyond the Greeks to the ancient Mesopotamian archer god Nergal. Sagittarius is known for its many nebulae and clusters, more than any other constellation. One of the largest and brightest is the globular cluster M22, big enough to be visible to the unaided eye. Located about 10,600 light-years away near the galactic bulge, M22 is more elliptical than most globular clusters. It's located just south of the ecliptic, the plane in the sky upon which all the planets orbit the Sun, and it contains over 70,000 stars, covering an area of around 100 light-years. It also contains at least 2 black holes, and is one of only a handful of globular clusters known to contain planetary nebulae, the puffed-off outer gaseous envelopes of dead Sun-like stars. Located in the sky next to Scorpius in the west and Sagittarius in the east is the constellation Ophiuchus, the healer or serpent-bearer, often portrayed as a snake coiled around a man. In Greek mythology, Ophiuchus raises Orion from the dead after he was bitten by Scorpius. Ophiuchus contains several star clusters and other interesting features, including Barnard's star. Barnard's star is the second nearest star system to the Sun, beaten only by the Alpha Centauri triple star system. Located some 5.9 light-years away, Barnard's star is a spectral type M red dwarf, about 0.144 times the mass of the Sun. Our Sun is around 4.6 billion years old. At between 7 and 12 billion years of age, Barnard's star is considerably older than the Sun and may be among the oldest stars in the Milky Way galaxy. It's lost a great deal of rotational energy, and its periodic slight changes in brightness indicate that it's rotating about once every 130 days. By comparison, our Sun rotates roughly once every 29 days. Given its age, Barnard's star was long assumed to be quiescent in terms of stellar activity. But in 1998, astronomers observed an intense stellar flare, indicating that Barnard's star is indeed a flare star. Flare stars are variable stars that can undergo unpredictable dramatic increases in brightness lasting a few minutes. It's believed that the flares of flare stars are analogous to solar flares in the Sun, in that they're generated by stellar magnetic energy stored in the star's atmosphere. Lying just to the west of the Scorpion is the constellation Libra, the Scales. In Greek mythology, Libra represents the claws of Scorpius the Scorpion. However, the Romans considered Libra a distinct separate constellation from Scorpius and thought them to be the scales symbolizing the equinoxes, the times of the year in March and September when the Earth gets equal lengths of day and night. That's because 2,000 years ago, when all this was made up, the Sun moved into Libra at the time of the September equinox. But due to precession, as the Earth's spin axis wobbles in direction, this point in time has now moved into the adjoining constellation of Virgo. If you look to the south in the Southern Cross, that's the constellation Centaurus, another half-man, half-horse mythical beast. Centaurus was the teacher of many of the Greek gods and heroes. He was placed among the stars in the heavens after accidentally being killed by a poisoned arrow fired by Hercules. Close to the pointer star nearest the Southern Cross, Beta Centauri, lies NGC 5139, Omega Centauri, the largest and brightest globular cluster in the visible sky. Because of its brightness, the ancient Greek mathematician and astronomer Claudius Ptolemy originally thought Omega Centauri was a star. It has a diameter of more than 150 light-years and contains an estimated 10 million stars, giving it some 4 million times the mass of our Sun. Located some 15,800 light-years away, Omega Centauri is another very ancient globular cluster, around 12 billion years old. And it contains many so-called population 2 stars. These are the second generation of stars to have formed, and were created directly out of the remains of the very first stars in the universe. Stars in the core of Omega Centauri are so crowded, they're estimated to average only 0.1 light-years away from each other. And that compares to the nearest star to our Sun, Proxima Centauri, which is some 4.2 light-years distant. Located close to Omega Centauri in the sky is the giant lenticular galaxy NGC 5128 Centaurus A, which we see looking like it's split in half by a thick band of dust. The galaxy was discovered in 1826 by astronomer James Dunlop from his home in what is now the Sydney suburb of Parramatta, a time long before the bright lights of a modern city would make such a discovery impossible. Located some 13 million light-years away, Centaurus A is one of the strongest radio sources in the sky and is thought to be the result of a merger between an elliptical and a spiral galaxy. It can be easily seen using a pair of binoculars, but you'll need a telescope to make out its spectacular dust lanes. August is also the time of the peak of the annual Perseids meteor shower. The meteors are the debris trail ejected by the comet Swift-Tuttle as it travels along its 133-year orbit through the solar system. As its name suggests, the Perseids radiant, that is the point in the sky from which the meteors appear to originate, lies in the constellation of Perseus. The Perseids are one of the oldest known meteor showers, with early Chinese historical records of its activity going back almost 2,000 years. They're active between July the 17th and August the 24th, with a peak on August 12th with around 60 meteors an hour being visible. The Perseids are very bright and fast-moving meteors, travelling at speeds of 59 kilometres per second. They're best seen between midnight and just before dawn, producing long, bright trails and some fireballs. Most Perseids burn up in the atmosphere at altitudes of over 80 kilometres. They're best seen from the northern hemisphere, so for southern hemisphere sky watchers, look to the north with the radiant below the northern horizon. Turning to the planets now, and 6 planets, Mercury, Jupiter, Venus, Uranus, Neptune and Saturn, will all align in the morning sky on August the 9th, with Mercury, Jupiter, Venus and Saturn visible with the unaided eye. Meanwhile, Venus will be close to Jupiter and visible in the constellation Gemini on August the 12th, while Saturn will appear to be close to the Moon on the same night. By August the 19th, Mercury will appear at its furthest apparent distance west of the Sun, which is known as greatest elongation, and Jupiter will have replaced Saturn as appearing nearest to the Moon. The following night, Venus will appear nearest the Moon, while Mercury will appear nearest the Moon on the 21st. And the new Moon will occur on August the 23rd. Finally, on August the 26th, the Moon will appear close to Mars, in the direction of the constellation Virgo. This is SpaceTime. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.
You're great at protecting your own personal information. You probably even use things like two-factor authentication, strong passwords, and a VPN. But as much as you try to be in control of how your information is protected, there are lots of places that also have it, and they might not be as careful as you are. That's why LifeLock monitors millions of data points every second for identity threats. If your identity is stolen, a LifeLock US-based restoration specialist will help solve identity theft issues on your behalf, guaranteed or your money back. Plus, all LifeLock plans are backed by the $1 Million Protection Package, meaning LifeLock will reimburse you up to the limits of your plan if you lose money due to identity theft. You might not be able to control how others handle your personal information, but you can help protect it with LifeLock. Save up to 40% your first year. Call 1-800-LifeLock and use promo code IHEART or go to lifelock.com/iHeart for 40% off. Terms apply.
We all deserve some yay in our day. So say hello to Hello. Hello makes oral and personal care products that add wonder to your routine, like a toothpaste that makes brushing fun for kids. It's called Unicorn Sparkle Toothpaste. It tastes like rainbows and sunshine, works brilliantly, and it's fun. So it's pretty much magic. And for the adults, Hello Anti-Plaque and Whitening Toothpaste, which is just as good, without the unicorns. Visit HelloProducts.com and let Hello add some everyday yay into your life.